So let me go ahead and share my screen. And we're going to start with question number 1. So question number 1 said, let R be the region in the first quadrant enclosed by the graphs of f of x equals 8x cubed and g of x equals sine of pi x as shown in the figure above or to the side for me. This is similar to the one that we went over in class when we were going over FRQs, right? It gives you a function, or excuse me, it gives you 2 functions. And then it gives us a picture, even though that picture doesn't label which function is which. And then it also gives us a point. Now, it's not always going to give you a point, but in this one it is. And so the picture also has additional information because we see that point of intersection is 1/2 and 1. So sometimes we have to find that point. In this problem, we do not need to. Okay. Part A does not ask about area or volume. Part A is a question you should be incredibly familiar with at this point. Part A is just asking us to write an equation of a tangent line. So let's see, let's grab my spinner app. Equation of a tangent line. Let's go to Drew Scheinman. What'd you do?
I took the derivative of f first.
Okay, so f of x is equal to 8x cubed. Okay, so your derivative of f was what?
24x squared.
Okay. What'd you do from here?
And then I plugged in the 1/2 for x to find the slope.
Okay, so hopefully you labeled that f prime of 1/2. Common mistake I see, so everybody make sure you're looking up at the screen. Common mistake I'll see is students will put an equal sign next to this 24x squared, and then they'll start plugging in the 1/2 here. Okay, that is incorrect because f prime of x is not the same thing as f prime of 1/2. Additionally, it must be labeled f prime of 1/2. So make sure you don't just like randomly have some floating work. And what I mean by floating work is just like off to the side, you have something like this shown without it set equal to something. Has to actually be set equal in order for us to give you points. Okay, so Drew's right. So far, we're going to plug in that 1/2. When I plug in that 1/2, what do I get here? So 24 times 1/2
24 times 1/2 squared. Yeah, so you get 6.
Perfect. Great. Okay, what'd you do from here, Drew?
Then I went back to the original equation and plugged in 1/2 to f of x. So then f of 1/2 equals 8 times 1/2 cubed.
Okay, so you don't have to do that here, Drew. Do you know why you don't have to do that on this problem? And a lot of problems you do have to do that. Do you know why you don't have to on this one?
I'm not sure.
Does anyone know?
It's on the graph.
Say that again, Carlos.
Yeah, it's on the graph.
Because it's provided for us. It's actually given to us already. So it's not wrong to include it, but you don't have to. Any information that's already provided to you, you don't have to show finding. Okay, so because that point is already provided, we don't have to find that. But again, it's not wrong if you did. It's good practice in general to make sure you're finding those points. Okay, so we know that the f of 1/2 is equal to 1. That should be provided. That is provided to us, or we could solve for that. Okay, what'd you do next, Drew?
Then I plugged it into the point slope formula. So then I got y minus 1 equals 6 parentheses x minus 1/2 parentheses.
Fantastic job. And I would always recommend starting with like y minus y1 equals m times x minus x1, like as your very, very, very first step, so that you know exactly what it is you're doing. Sometimes it's stressful. And then we solve for something like f prime of 1/2 and we think we're done. So make sure you know exactly what it is you're finding. Excellent job. Let's talk about any questions on this so far? I want to talk about the points and how they work. Okay. You're not going to see every step shown in the rubric, just to clarify. So sometimes the rubric, it looks like this. I want to show you what like a College Board rubric looks like. That does not, if you copied this down exactly, you would not necessarily get credit because the rubric skips a lot of the steps of work that we would expect to see. Okay. It's just showing us specific like checkpoints for us to be able to grade, but we're still looking as graders for all of the work in between. So I don't want you guys to think, oh, I showed exactly what the rubric showed. I got 100% correct. That's actually not true. Okay. So what we noticed is f of 1/2 equals 1. You can write that down. You actually don't have to because it's provided. You do need to find f prime of x. So in your work, you have to find f prime of x. You'll notice off to the right, this problem is worth 2 points. Finding f prime of x is not worth its own point, but you can't get any points if you do not have that written down. So you have to find f prime of x, which equals 24x squared. Now, like I said on that last one, if you had set f prime of x like here, and you had just started plugging in the 1/2, we would actually stop grading. So if you have like f prime of x equals 24x squared equals, and then you plugged in a 1/2, you get 0 points on this problem. Okay, so we would stop grading this question. So grade yourself honestly so that you know and you have feedback on how you're doing. Okay, after you find f prime of x, then we can find f prime of 1/2. Again, I would encourage you to show your steps just like Drew did. We get f prime of 1/2 is equal to 6. And then you have your equation of a tangent line, and your tangent line equation, they've moved the 1 over. You don't need to do that. It's fine if you did, but you don't need to. So as we said, y minus 1 equals 6 times x minus 1/2 is the final answer. That is worth the second point. So 1 point for f prime of 1/2, provided you have f prime of x. And then if you didn't get that, you cannot get the second point, no matter what. Okay. So that second point relies on the first point. Okay, and this problem is out of 2 points. Any questions on this? Okay, let's move on. Part B says find the area of R. So find the area of R. Well, area is top minus bottom, right? That's how we find area. So we need to know which graph is which. We're given two functions. One is 8x cubed, so that's a positive cubic. So a positive cubic in general looks like this. Ooh, that's kind of hard to see on there. Sorry about that. Positive cubic looks like this kind of a shape. And then we also have a sine graph, and a sine graph in general looks like this, right? That's in general what our sine graph starts to look like. Okay, so you should be able to tell that this one right here is our g of x, which is equal to sine of pi x. And that this other one down here, this one is actually our f of x, which is 8x cubed. Okay, so for find the area of R, let's go to Riley. Riley, what'd you do?
I started off by taking writing it into the formula that we use. So instead of writing A equals, I wrote area equals.
Thank you, Riley, because that's absolutely necessary. Please mark yourself off if you wrote A equals or even R equals. You need to write the word area equals. Fantastic. Keep going.
Then the integral from x equals 1/2 to x equals 0.
X equals 1/2 to x equals 0. I think you mean it the other way. I think you mean from 0 to 1/2. So we always start with the smaller one. Yeah. Okay. Perfect. All right. From here.
Then in parentheses, sine pi x minus ax cubed dx.
Excellent. Excellent job. Okay. If you do not have this, you can give yourself a 0. We would have stopped grading already. Okay. So you need to have this first. This whole thing is worth the first point. Having this correct is worth the first point. Okay, so if you don't have this written down exactly like we've got shown here, you do not get any points. I guess technically you could have written 0 to 1/2 of g of x minus f of x, but I like that Riley just wrote the functions because we actually have to solve this. If we didn't have to solve, then yeah, we'd probably leave it as f of x or g of x. Okay, from here, I am going to take over. Riley, we'll come back to you shortly. Okay, what I would recommend doing is breaking this up, since we're going to need some u substitution. And this is where a lot of you will miss a lot of these points. So like we talked about last class, when we break this up, we can call it 0 to 1/2 of sine of pi x. That's really where I need the u substitution and a dx. And then I can do minus the integral from 0 to 1/2 of 8x cubed dx. Couple of reasons students miss point. One, something's not labeled. We don't have area equals. Other reasons, they forget the dx, or especially if they split up their integrals, they forget those dx's. You need a dx anytime you have an integral, has to come at the end of whatever you're trying to integrate. Okay. Now the next mistake often comes with the u substitution. We went over this last class. We're going to do it again today because I want to make sure we feel more comfortable with our u substitution. We definitely struggle with that for sure. So our u substitution, let's choose yellow here. We're going to choose our u is equal to pi x. Okay. If you don't have this shown, or if you feel like you found a quicker way or something, make sure you're marking this up
I'm talking to you.
on your paper so that you get this correct in future problems. Okay. The next step would be du equals pi dx. And then I would divide over the constant. So I'd have 1 over pi du is equal to dx. So that allows me to change this integral to 1 over pi, the integral of sine of u du. Now, what I've seen from some of you is you just leave your bounds off. You're like, I don't want to figure out my new bounds. I'm going to go back and plug in my x later, and I'll plug in my old bounds later. We would stop grading if you left off bounds here. Even if you got the right answer, you have to write bounds because otherwise this thing is not equal to this thing. One is a specific bounded integral and one is not. So you do need to find new bounds. Riley, we're going to come back to you. How do you find those new bounds?
I didn't find new bounds. I did the long way and just put pi x back in for you.
Okay, so just to clarify, we would stop grading on that, and so you wouldn't get more credit. You would stop at that 1 point. So it is actually important we know how to find those new bounds. Do you know how to find the new bounds, Riley?
Yeah, so we would plug in u4, or we plug in 1/2 and 0 back into the pi x.
Exactly. And so a lot of you do that. A lot of you do it the long way because you're more comfortable with it. I'm really trying to emphasize how important it is because we'll stop grading, but also it's a really important topic on the test that you need to know how to do. So Riley knows how to do it. He just chose to do it a different way, but that's going to affect his points here, even if he gets the right answer. So let's make sure we're showing this. So we're plugging our 0 into u equals pi x. So we get 0 as our bottom bound. And then we plug 1/2 into u equals pi x. So we get u equals pi times 1/2. Or the same as pi over 2. Now that we've changed our bounds in this yellow portion, we are never going to go back to x's on the yellow portion. We're going to leave it in terms of u. Okay, so now I take the integral of sine of u. What's the integral of sine of u, Riley?
Negative cosine. Pi
Excellent.
over 2.
Good. So we get negative cosine of u, and we're going to go from 0 to pi over 2. So we're going to get 1 over pi. We're going to get negative cosine of pi over 2 minus a negative cosine of 0. Totally okay if you write plus there. Okay. And now we're going to evaluate. So again, here's where you got to know your unit circle. These aren't hard unit circle values, but you got to know them. So pi over 2 is up here, right? If I'm looking for cosine, I'm trying to think about what the x coordinate is up here at pi over 2. The x coordinate at pi over 2 would be 0. So I would have 1 over pi times negative 0, which is just 0. And then negative is plus. Cosine of 0 means what is the x coordinate when the angle is 0, which is 1. So we get 1 over pi for that portion. Okay, we didn't go back to our 0 and 1/2. We didn't go back to pi x. We left everything in terms of u once we changed it. Okay, now we're going to do the right-hand side one. So that right-hand side one, we have negative 0 to 1/2 of 8x cubed. So the next thing we would have would be negative, what's the antiderivative of 8x cubed, Riley?
4x or 2x to the 4.
Okay, so 8x to the 4th over 4, just to clarify, and then you can simplify that to 2x to the 4th. Excellent job. And we don't need a c here because we have bounds. Be careful, if we didn't have bounds, we would need a c. Okay, what's the next step, Riley?
Then you could just 2 half to the 4 minus, 0.
Yeah, minus 0. And you don't have to show plugging in that whole 0 thing if you know it's going to be 0. Just be careful if it's e to the something or cosine of something, it's not just 0. Okay, 1/2 to the 4th, we're really thinking about what 2 to the 4th is. So 2 times 2 is 4 times 2 is 8 times 2 is 16. So we get a 2 times 1 over 16 or 2 over 16, which is minus a 1 over 8. Okay, so our final answer here would be 1 over pi. Area equals 1 over pi minus 1 over 8. Any questions on that problem?
Ms. Toshner?
Yes, sir.
So when I did this, I used u sub to get the 1 over pi in front, but I didn't redo the bounds. But I still got the right answer in the end. Would you lose points for that?
Absolutely. We would stop grading entirely. So that's the problem because You've changed a bounded integral to an unbounded integral and back. So even though you got the right answer eventually, because your middle steps are wrong, we don't even look at the final answer. That's what I'm saying. That's why this is so important, this step right here. And I'm emphasizing that because a lot of you skip that step in your work, and we would just stop grading because your integral is no longer equivalent. Okay, even though, yes, you get to a right answer. Yeah. Did you have something else? More questions?
Miss Tasha, I have a question. So I put R instead of area. So would you stop grading if you put?
So R is just the name of the region. That's not really what you're finding. R is what the region is called. What you're finding is area. So it's up in the, like, a person is actually going to grade your test. So they might give you credit on that, Dominic, but like, maybe not, because that's not what you're finding. So it's potential that you could get a 0 on this problem just for writing that. So you will definitely get credit if you write area equals. Use your discretion on this one, but know that I will probably give you a 0 if you write R equals. Okay.
Okay.
Good question. All right. Let's talk about, yeah, go ahead.
So if for part B, if you didn't even use U sub, would that still be okay or no?
So you should be using U substitution because we need U substitution here. So some of you are just like taking this like fast way of dividing out the derivative of the function in the inside. And it's going to get you into trouble because the AP calculus exams know that you do that. And so they intentionally put questions in here that if that is your like fast trick method, you're going to get some wrong answers, especially on multiple choice. So I would like to see the U sub if you need U sub. Could you potentially get credit? Yes, you could potentially get credit. On this problem, I would not give yourself credit, and I'll talk about where the points come from in a second because I want to see the U sub. You have to know U sub. We need to practice that U sub if you're trying to find faster or trickier ways. Like I promise, if there's the fast way, I want you all to get 5s. I would tell you like, always use this because it's always going to work. I would tell you that. That way is not always going to work, which is why I really do emphasize the U substitution. Okay. All right. So let's talk through points here. So first point again was that setup, the integrand itself. So 0 to 1/2. Notice they have area equals. Make sure you have area equals. The 0 to 1/2 of the function minus the other function. You need the dx. Okay. That's the first point. The second point is, there's 2 points next. You can get one or both of those. Okay. So you can get, you could get a total of 3 points on this problem, or 2 points or whatever. So that second one is individual points, those 2 antiderivatives. So that means you get 1 point for this antiderivative, the negative 2x to the 4th, and you get 1 point for this antiderivative, which is the 1/pi times negative cosine of u. Okay. So you get a point for each of those. If you didn't change your bounds, that means you could get a max of 2 points on this problem. So if you didn't change your bounds or you didn't write that U substitution, you would get a max of 2 points and then we would stop grading. Okay, so that's how you should grade yourself today. If you forgot the 1/pi out here, even if you included it later, you could not get that point. Okay, so right now there's 3 points possible. Fourth point is for the answer. You cannot get that answer if you didn't get all the points before it. Even if you got the right answer, we would have already stopped grading. Okay, so the final answer, 1/pi minus 1/8, that's your final point. But again, you can only get that if you haven't missed anything leading up to that problem. Are there any questions on this one? Okay, let's go to part C. So part C says, write but do not evaluate an integral expression for the volume of the solid generated when R is rotated about the horizontal line y equals 1. We talked about this in class. It's really, really helpful to draw all over your picture. I know that this was online, so you guys don't have like, unless you have a printer at home or something, a way to print this out. But I would always encourage you to draw the picture and then draw all over it. I'm hopeful that the exam in May will be on paper, so you actually have something to draw on. But if it's not, get in the habit of drawing these things yourself. Okay, so we're rotating to about y equals 1. That's up here. I would always label that in your drawing. The next thing we're going to do is we're going to set up the bones of our equation. Dominic, what do I mean by setting up the bones of our equation?
You would write volume equals pi times the integral of parentheses squared minus parentheses squared.
Perfect. Exactly right. That's the bones. Okay, now we know we're going to need a dx or a dy.
Yeah.
Dominic, which one is it going to be?
Dx.
Why?
Because you're dealing with a horizontal line? Or
Yes, because we are rotating it about a horizontal line. So anytime I am rotating it about a horizontal line, we are going to use dx. Excellent job. Okay, so we know we're doing a dx integral, meaning everything is going to be in terms of x. Dominic, what would my bounds be here?
0 to 1/2.
Fantastic. Okay. You'll notice, just like we did in a practice problem, this says write but do not evaluate, which means all the points here are just going to come from the setup. All we have to do is set it up correctly, but it's really important we get that set up correctly. Okay. The next thing we're going to do, Dominic, is what?
You would find the R out. So
Okay. How do we do that?
you would put like a point on the horizontal line and then draw your pencil like down to the farthest.
Until where?
Until you hit the farthest curve.
Correct, to the farthest curve. Exactly right. So this is our R out. That's what we're looking for R out, right? The distance from here to here is the function, and that function is 8x cubed. Okay, or again, you could just call it f of x. It's totally fine to call it f of x since we're not really evaluating this, and they give us f of x, you could call it that. Okay, and then this total distance here from the x-axis to that curve is 1. So Dominic, what would my R out be?
1 minus 8x cubed.
Perfect. 1 minus 8x cubed, or again, it's equivalent if you wrote 1 minus f of x. So this exact same thing, if you wrote 1 minus f of x, that's fine as well. Okay, make sure you have the bones, make sure you have that squared, make sure you have the minus and all that stuff. Okay, and we're going to do the same thing with the other one. So the same thing over here. Let's choose blue. Okay, so we're going to put our pencil on the thing we're rotating it about, and this time we're going to draw it to the closer curve. Again, the distance from the x-axis to that curve is g of x, or our sine of pi x. The total distance is 1. So what would your setup for this next part, for our R in be?
1 minus g of x.
Perfect.
Pi of x.
Okay, so, or you could call it sine of pi x, right? There's not one that's better. It's up to you, whatever you prefer. Okay, that's it. That's all we have to do. Points here. You'll notice this is exactly what the rubric looks like, and they'll give us options. So we have either or. The first point comes from the limits and the constant. So that means, oh, this should say volume equals, by the way. I don't know why this rubric cut that off, but it did. It always says volume equals. Make sure you have volume equals, not V equals, not R equals, volume, the word. Okay, first point comes from this portion. So you need the pi and the 0 to 1/2, meaning if you forgot the pi because you forgot to set up the bones of your equation, you get 0 points on this problem, even if everything else is right. Okay, make sure you have the pi and the 1/2. The next 2 points are all or nothing. So on a previous problem, we saw where we had 2 points and you could get one or the other or both. Okay, this problem is different. You have to have it completely correct in your integral. Otherwise, you cannot get those second 2 points together. And so what that means is you need to have this entire equation with the dx, and that's worth an additional 2 points. Or you could have this entire equation. So you're not required to use the functions. You could use f of x and g of x, as long as you have everything in there and it's correctly written, squared, the correct order, all that stuff, then you get those next 2 points. That's out of a total of 3, so give yourself a score out of 3. Every FRQ you're ever going to take is going to be a total of 9 points. So there were 3 points on this one, there were 4 points on part B, and there were 2 points on part A. Give yourself a score out of 9. And be honest, and it's okay. I don't expect us to be getting 9s right now. Okay, hopefully eventually, but right now I don't expect us to be getting 9s. I expect this to be a learning process. Let's go on to questions. Yes, sir.
Sorry. So for B, if we did not do U sub at all, what would you say the score would be?
2 points.
2? Okay.
Yep.
Thank you.
Yep, because you would get that other, assuming you got the antiderivative negative 2x to the 4th correct, which I assume most students did. Okay, then you would have max of 2. If you messed up that second derivative, you'd have max 1. Okay. Any other questions before we move on?
Miss Tasha, on the last one, if you went straight to that equation that you have written below, do you not get full credit?
You definitely
The-
get full credit. I'm confused on what you're asking.
So you
Without
don't
skeleton.
you don't need that skeleton part that says like 1 minus f of x squared minus 1 minus g of x
No,
squared?
you either or. So it would be full credit
Okay.
if you wrote either this one, or it'd be full credit if you wrote that second one. Either or, full credit.
Okay, that makes sense.
Yep.
Thank you.
Some students just prefer to like make it a little easier on themselves without having to write the function. It's fine either way, doesn't matter. Okay, good question. All right, let's go on to question 2. So let R be the region bounded by the graphs y equals square root of x and y equals x over 2 as shown in the figure above or to the side. Again, hopefully you have this drawn on your paper. Again, it's not labeled which one's which, but we can figure this out. One is a line, one is a square root function. And again, it gives us a point, the point of intersection. So we can see that there. Part A says find the area of R. Just for purposes of time, I'm going to go through this a little bit quicker so that we can get to that last one. So we have area equals. We have the integral from, we should go from 0 to 4. Make sure you go from x to x or y to y. Okay, we're going to do this with respect to x. We're going to do top minus bottom. Our top curve is this square root of x one. Our bottom curve is x over 2. So we're going to go square root of x, or the same as x to the 1/2 minus 1/2 x dx. I like to write it this way because I think it makes the integrals easier. You can write it however you want. If you want to call it square root of x, if you want to call it x over 2, I just think it's a little easier to do this. Next thing we're going to do is we're going to take the integral. So x to the 3/2 over 3/2. That's how I like to do that. And then minus a 1/2 x squared over 2, or the same as a minus 1/4 x squared, and we're evaluating this from 0 to 4. Okay, now we're going to plug this in. Some guys get confused on what that to the 3/2 means, because we're going to have 2/3 times 4 to the 3/2 minus 1/4 4 squared. And then we're going to subtract 0. So I don't really need to show that. You can if you want to like be extra careful, but you don't need that subtract 0 because in this case it is just a 0 there. So I'm going to erase that. Just to clarify what 4 to the 3/2 means, because you're going to encounter that a lot on AP Calc. 4 to the 3/2 is the same as writing the square root of 4, that thing cubed. Some students only think that it means where the cubed is on the inside. Those things are equivalent. And usually it's easier to do the square root first and then do the cubed. So I recommend thinking about it that way. If you got stuck there or you needed a calculator, write that down so you understand. So we're going to get 2 cubed, which is 8. So we have 2/3 times 8 minus a 1/4 times 16. So that's 16 over 4, which is 4. We get 16/3 minus, we're going to be subtracting a whole number. So I'm just going to change that 4 into 12/3, which gives us 4/3 as our area. One thing you'll notice, all of my work is not floating work. If you guys have seen me write that and you're not sure what I mean, I set up area equals here. I wrote what I'm finding. I labeled what I'm finding. That's step 1. Then I had an equal sign all through here to verify that all of those things are equal to the area. That avoids floating work. If you're missing those equal signs, you have floating work and you're going to get marked off because we no longer know what you're finding. We're idiots when we're grading apparently. And so if you have floating work, if things are not labeled, you lose points on that. I'll be lenient here, but just make sure if you're missing those equal signs or if you don't have things labeled that you make those adjustments. Okay. Points on this problem. Again, you'll notice the rubric, they skip a ton of steps. The rubric is not intended to show the work to get to this answer. It's intended for the reader to have checkpoints. So if you look at this rubric and this is all you have written down, you would not fully get credit because you didn't actually show all that work. This is all the work I would expect to see here, right? We've got plugging in, we've got evaluating, simplifying, all that kind of stuff. Okay, rubric. First point is the integrand. So area equals the integral from 0 to 4 of square root of x minus x over 2 dx. If you forgot the dx, it's a 0 on this problem. Stopped grading. Didn't care about anything else. Okay. Again, you can write that as x to the 1/2. You can write it as minus 1/2 x. The next point, so point 2 comes from the antiderivative. So 2/3 x to the 3/2 minus x squared over 4. That's the next point. And then the final point Make sure you have that with the 0 and the 4 here, by the way. So it should look, you don't have to have x equals 0 and x equals 4, but you need this line where it's set up like this. Some of you on a previous test were showing integrals still in front of here. That would be wrong and I would stop grading. So you would only get 1 point if you showed another integral there. We would not include that as a right answer if you have another integral shown. Okay, same thing goes if you forget the vertical line with the 0 and the 4, you would not get that second point. You would have max of 1. Final answer is 4/3. That is our third point. So give yourself a score out of 3 on part A. Are there any questions on part A?
I have a quick question.
Go ahead, Matt.
I was just wondering if you get points off if, like, for there you didn't need to split that integral into 2 integrals, but I accidentally took an extra step here.
Excellent. As long as you've got a dx on both, Matt, no issues. So I think what you're saying is you wrote one integral from 0 to 4 of x to the 1/2, and then you have like minus another integral of 1/2 x dx, or however you chose to write that. Totally fine if you did it that way. There's no difference really. If you want to, if that's easier for you, do it that way. Just make sure you have a dx on both. Otherwise, it's worth 0 points.
All right, thanks.
No problem. Other questions? All right, let's go to part B. Part B says, all right, here's where we get interesting. The region R is the base of a solid. For this solid, the cross sections perpendicular to the x-axis are squares. Okay, this is that brand new topic we just talked about last class. So it's important to understand that when it's now asking for volume, some guys get confused. They see this word volume and they assume, oh, I got to set up that pi, something squared, something squared. No, if you see this word cross section, that means we have to take that other approach that we talked about on Monday. Okay, so we have cross sections. The first thing I would do is draw one little cross section. So we have cross sections perpendicular to the x-axis. That means this portion is going to be my base. That little line, so perpendicular to the x-axis, is going to be my base. So now I want to come up with an equation for that base. So my equation for base is going to be, well, let's think about this. So the distance from the x-axis to that top curve, that distance is rad x. The distance from the x-axis to the bottom curve is x over 2. Okay. And so now our base is going to be the difference between those. So it's going to be rad x minus x over 2. That's going to be our base. Okay. Now what we want to do is we want to come up now with an equation for area regarding whatever shape we're given. So in this case, we're given squares. Squares are probably pretty common. Okay, there's other shapes we can do, rectangles. We can do what sounds hard, an isosceles right triangle. It's actually just half of a square. Or sometimes they'll do a semicircle or a quarter of a circle. Okay, but most common I would say is squares. So the area of a square is just our base squared. And we want to make sure we're writing our area equation in terms of our base. Well, in this case, that means it would be square root of x minus x over 2 squared. The next thing we do, now that we have that area equation, is we're going to integrate, because in order to get a volume, which this still is a volume, so you should label it volume equals, we're going to integrate the area. So we're literally going to integrate this equation. Square root of x minus x over 2 quantity squared dx. You'll notice there's no pi in this one, because there's no pi in the area of a square. The reason there's a pi in that other one is because we're coming up with a circle, right, when we're rotating. So that's where that pi comes from. There's no pi in this equation. There's no something squared minus something else squared. Okay, it's just the integral of the area. We do still need bounds. So the bounds here are going to still go from 0 to 4. Okay, that's our setup. Any questions on that setup here? Okay, for purposes of time, we're not going to walk through this whole integral and solving it. You would have to FOIL that out in order to take the integral. So you can't just make it like cubed over 3. You have to actually multiply it out and FOIL it out. And then you get the integral of x minus x to the 3/2 plus x squared over 4. You'll see that in that second step. Right here, they FOILed that out. You need to take the integral of that, which is shown over here. You're still taking it from 0 to 4. It's fine if you don't have your zeros and your 4 on there. Again, this is not sufficient work. At this point, you would actually be plugging in your 4, evaluating, simplifying your equation, and you'd get down to 8 over 15. This is worth 3 points. First point is the setup. You need to have volume equals the integral from 0 to 4 of square root of x minus x over 2 squared. First point. Second point is the antiderivative. Obviously, you can't get to that antiderivative unless you have this intermediate step. So don't skip that step, but it's not worth its own point. But you have to have it in order to get the other points. Okay, so point number 2 comes from the antiderivative shown here. Point number 3 is our answer, 8 over 15. Okay, give yourself a score out of 3. Okay, part C, write but do not evaluate. Those are our favorite ones because all we have to do is set it up, and then that's where all the points comes from. It says an integral expression for the volume of the solid when R is rotated about the horizontal line y equals 2. This is very similar to the one we just did because it's rotated up again. Note, it's not always going to be rotated this way. It will occasionally be rotated this way. That's in that other video I showed as well. So make sure you watch that if you need to. I'm going to run through this just so we have time to talk through the last one because that one is the most confusing one. We're going to have our bones. So volume equals pi integral of something squared minus something squared. I am rotating it about a horizontal line, which means I'm going to have a dx, meaning my bounds are going to be in dx, so 0 to 4. And now I need to figure out what my r out is and what my r in is. So for r out, I'm going to draw a dot on the thing I'm rotating it about to the furthest away point. I recognize in this case that the distance from here to here is x over 2. This total distance here to here is 2. So I have the difference there. So I get 2 minus x over 2. In this case, you cannot call it f of x because they're both called y, right? So you have to be careful here. You can't use f of x because they're both called y. You can't use g of x. You actually have to use the function. So 2 minus x over 2. Then we're going to do a very similar thing when we're going to find the other portion. So on the thing I'm rotating it about, on the thing I'm rotating it about to the closer curve, the distance from here to here is square root of x. The total distance is 2. So again, I have a 2 minus, and in this time it is the square root of x. That is what you need for this problem. Okay, let's go through the points here. Volume equals, this is all they have written. First point comes from the limits and the constant. Again, you gotta have that pi. If you forgot pi, 0 points. That's why I always recommend setting up the bones first, because pi is part of those bones, makes it easier to remember. Okay, that's the first point. Second point is all or nothing, or excuse me, second 2 points is all or nothing. So 2 minus x over 2 quantity squared, need parentheses there, need a minus sign. 2 minus square root of x, quantity squared, need a dx. 2 points for this whole thing, exactly correct. Okay, give yourself a score out of 3. Give yourself a score out of 9. I know we're running a little short on time. Can you guys throw in the comment, if you're not embarrassed to do so, what your total score is out of 18? By the way, a score like of a 50% is pretty good. Okay, so if you're anywhere like near a 50%, that's pretty good. So if we can see some scores, just throw them up. I don't really care. No one's looking. I just want to get an idea of where we're all at. So some 14s, 15s, 13, good. Do we have any like 5s or 6s? I would expect some of those also. Yep, looks good. Good, good, good. Again, if we're around a 10 or a 9, that's excellent. So if you're above that, that means you're feeling pretty good about this topic, I would say. So you should feel very proud. Okay. Just a reminder, on the AP exam, a 5 is generally about like a 65%. A 4 is generally about a 50%. Okay. So that's why I'm saying if you're getting like a 9 out of 18, that's like a 4. Okay, obviously there's a lot of content on this exam, so there's a lot of places to make mistakes. Also, you might know this very well, but you might have missed a DX, and then that caused you to lose like 3 or 4 points. So just be mindful of that. Okay, last one. I've got 8 minutes. Let's talk through this. Find the area of R. This first one was a very different question for a lot of you because of the way that this picture is drawn. So we have this picture here. We have f of x on the left side, g of x on the right side. It actually labels it for us this time. That's nice. They didn't need to do that. Okay. And it asks us to find the area. The issue with finding the area on this one feels like I don't know which one is the top curve and I don't know which one is the bottom curve. Like a lot of guys look over here and they get confused. They're like, I don't know, it looks like g of x would be on top or maybe f of x would be on top. Well, if you're looking at these curves and we're doing top minus bottom, over here, the top is f of x. The bottom is just the x-axis, right? And on the other side, the top is g of x and the bottom is the x-axis. So you need two integrals. We're going to talk about another way you could potentially do this problem, but I am assuming if you did this correctly, you wrote area equals, you had one integral that went, we're going to essentially split it right here. That went from 0 to 4 of that curve. So that curve is the square root of x1. And that's going to account for this area here between square root of x and the x-axis. Okay, and so again, we need a dx there. And then we're going to add that to the other area. So the area from 4 to 6 of 6 minus x dx. That's going to account for this area. So you're not doing square root of x minus 6 minus x, and you're not doing 6 minus x minus the square root of x. You are finding those two areas and then adding them together. Okay. I'm not going to spend too much time walking through this integral itself because the integral itself is not the hardest part of the problem. The hardest part of the problem is the setup, making sure you set this up correctly. Okay. There is one other way that you could do this where you would use one integral and then you would find the area of the second part without an integral. So an equivalent but different method that you could take, right? So this is one way. You'd take those integrals, you'd plug in those values, just like we've done, and then you'd add all that stuff together. Okay, the other thing you could do was you could have area equals, you'd still need the integral for this first part, square root of x dx. Can anyone think of a different way besides an integral to find the area of that second piece?
You could just take it like the...
Or go ahead, Jack, sorry.
You could take it like the area of a triangle.
Perfect. We could just find the area of a triangle. So we don't actually need to take an integral here, right? It might be a lot faster to look at this and say, oh, well, this area is 1/2 a base of 2 times a height of 2. Wow, then I don't even have to take that second integral and plug in all those values. I can just evaluate it this way. And that's exactly the work you'd show. You could show it like this, 1/2 base times height. You don't want to skip to a value because we want to see what you did. So if what you were doing was taking the area of a triangle, you should write out like a 1/2 times something. But that's also totally fine if you took that approach. Okay, either is correct. The second one is only a little bit better because it's quicker, but it's no better as far as like a method goes. It's totally fine either way you did it. Okay, let's talk through the points here. So you would get 1 point for the integral. So the setup here, again, that would either be this, as you can see, they've got it shown like I talked about in the second part, 1/2 2 times 2 for that second part, with the integral from 0 to 4 of square root of x. That would be worth your first point. Or if you did it this way, that whole thing would be worth your first point. Okay, so that's the first point here. Point 2 is the antiderivative. So the antiderivative, if you just had one integral, would be 2/3 x to the 3/2. Or if you had both integrals, you'd have that 2/3 x to the 3/2. And then you'd also have a 6x minus x squared over 2. Okay, so if you broke it up, you'd have those two integrals, and that would be worth the second point. Okay, so 1 point for your setup with either 1 or 2 integrals, depending on how you showed that. And then the second point is for the antiderivative, either 1 antiderivative or 2, depending on which method you chose. Okay, and then finally your answer should be 22/3. We're running out of time, so I'm not gonna have time to walk through all of that. Questions on this?
What if we use y?
Oh, you could also use y. Carlos, you're so smart. So you could also set this up in y if you wanted to. So if you wanted to do, because he realized, oh, I don't have a top minus bottom, Carlos could do a right minus left instead. What you would have to do for right minus left is you'd have to change this you'd have to change this guy. So instead of y equals x over 2, you get multiply by 2. What would that be? Oh, so 2y equals x, right? Oh, this is 6 minus x. That was a different one. Sorry, y equals 6 minus x. So then you get x equals 6 minus y. And then you'd also have y squared equals x. So what you could do, and I'm assuming this is what you did, Carlos, you could have area equals the integral. You'd go from 0 to 2 instead, because you'd be in terms of y. And then you do your right minus left. So 6 minus y squared dy. If that's what you did, totally fine, 100%. You're going to get exactly that same value, Carlos. 22 over 3 is the final answer. Great. And that one maybe is faster or easier to see. Excellent job. Okay, 3 points possible here. Next problem says the region R is the base of a solid. And we're actually going to need to use this like with respect to y for this one. Okay, so it says for each y, the cross section, so this tells us we're doing a cross section perpendicular to the y-axis this time. So cross section perpendicular to the y-axis means I'm taking a slice this way instead. And now that's going to be, well, I'm writing sideways. That's going to be my base, that length. Okay, so just what we just talked about with Carlos, this equation becomes x equals 6 minus y, right? That's what we had, x equals 6 minus y, and x equals y squared. All we did was isolate the x instead of the y. So we have those two equations, okay? Now the distance from this curve to the x-axis is that y squared. The distance, from the y-axis to that curve is y squared. The distance from the y-axis to the other curve is this 6 minus y. And so we're subtracting them. So our base is going to be 6 minus y squared. Now the shape here is a little different than we've dealt with. So it says, I know the bell's about to ring, or it probably just did, but just give me 1 second to finish this up. It said whose height is 2y. So we have a rectangle whose height is 2y. So area really equals a base times a height. Our base is 6 minus y squared, and our height is 2y. Like that is our height. Our height is 2y. So now we're just going to integrate that. It's a write but do not evaluate. We would have volume equals, I'll show you on this next slide. Volume equals 0 to 2 of 2y times 6 minus y squared dy. You get 2 points this time for this portion. So the squiggled underlined, that's 2 points, and 1 point for those bounds. And that would be 3 points possible. I know we didn't quite finish. For that last one, you should have set this equal to each other. You should have set up an f prime of x, and you should have this as your coordinates, and that's 3 points. Okay. That one really wasn't area or volume. It was understanding what a perpendicular to a line was. Perpendicular means we would have the opposite slope. We found the derivative, set it equal to that +1. Found the x, and then it asked for the coordinates. So we need to define the y coordinate as well. Okay, I'm way over time now. I will stay on if anybody has any questions, but you can give yourself a score out of 9 based on this information, and a score out of, we did 3, so 27 altogether. Okay, I will see you guys. I don't think we have class. Oh, we have class Thursday. I'll see you Thursday.
Thank you.
Thanks, guys. Sorry to run so long.
Thank you.
Thanks, guys.